The rectangular tank showed here with its top at ground level is used to catch runoff water. Assuming that the water weighs 62.4 pounds per cubic feet, how much work is done to empty the tank by pumping the water back to ground level once the tank is full? So this is ground level right here, so this is my 0, and then going down is now my positive numbers. So the lower I go, the bigger my number. So we pretty much took my y-axis and flipped it around. So now this is positive y. So the first thing I need to do is I need to know, well, I know that work is going to be my force multiplied by my distance. So I need to know my force first. And I know that the force is actually going to be the weight of the water. So I'm going to take this piece right here and I'm going to find the weight of this piece. Well, the weight of this piece is going to be the volume of that piece multiplied by its density. So the volume of this piece is actually going to be 10 by 12 by this length, which is going to be delta y. And we're going to multiply that by 62.4. To get my density, and then if I take my density and I multiply by the volume, that will give me my weight. So my weight, if I actually multiply this out, ends up being 7488 delta y. So that is going to be my force. My distance traveled is actually going to be, it's going to be a little different than class, but the distance is actually just y because it's going to be going this way. The distance is going to be y. So the distance traveled is going to be just y. So distance is y. So then we have my force times my distance. Well, distance is a function of y, which means I have to do an integral. So it's going to be an integral of this, 7488, and then delta y becomes dx, dy, sorry. And then we're going to multiply by y, and we're going to integrate from 0 to 20 because it's full of water. So that is actually going to be 1/2 of this, which is actually going to be 3744 multiplied by y squared. That came from doing this. And then the integral of y is 1/2 y squared. And I just divided this by 1/2 to get this number right here. And then we're going to evaluate that from 0 to 20. Well, if I plug 20 into here, I end up getting 3744 multiplied by 400. And that ends up being 1497600 foot-pounds. So that is the amount of work it takes to pump all this water back out of the tank. Now, I'm going to erase this. And I'm going to take this piece right here. Let's erase this right here. And we're going to save this for later. So that was A. If a water is pumped to the ground level with a 511 horsepower motor, with a work output of 250 foot-pounds per second, how long will it take to empty the tank to the full tank to the nearest minute? Okay, so we know that it's going to be this much amount of work. And this 250, if I multiply by 250, that will give me foot-pounds squared over seconds, and that's not what I want. I want time. So if I divide by 250, foot-pounds per second. And I flip and multiply. This will go away with this, and this will go up to the top, which gives me seconds. So if I divide this out, I end up getting 5,990.4 seconds. So if I want to round that to the nearest minute, that's going to be 5,990.4 seconds. And I need to multiply that by 1 minute for every 60 seconds. If you notice, the seconds are going to go away. And so this divided by 60 ends up being 99.48 minutes. And the book says 100 minutes. But I would say it's closer to 99, but we'll let the book have it. Okay, so that is going to be my answer for this piece. Now let's erase the rest of this work again. Show that the pump in part B will lower the water to level 10 feet during the first 25 minutes of pumping. So that means I am going to be integrating that same integral. So I'm going to be integrating from 0 to 10 this time because we only want half of this to be gone. So I'm only going to go from here to here of that same integral. And that integral, once again, was 7,488 y dy. And if I integrate this again, I get 3,744 y squared, but this time I'm evaluating from 0 to 10. So if I plug that in, we end up getting 3,744 multiplied by 100, which ends up giving me 3,74400 foot-pounds. And if I take that same pump, I need to divide again by 250, which ends up giving me 1497.6 seconds. And if I convert that, that's going to be the same thing as 25 minutes.